Math 230, Cuesta College. I'm Joe Vasta, and let's start this video here. We are going to cover section 1.1, which is titled Sequences. So this is our first official section where you'll be doing homework. Let's just remind you that a sequence is a list. That's all it is. Now in math, lots of times it's a list of numbers. And I'm going to write numbers in this class like that. That's number. And then I better put an S to plural it. There we are. So a sequence is a list of numbers. And what we're going to do is we are going to look at patterns in section 1.1. That's what a lot of mathematicians look at. You would not know that by taking algebra classes. An algebra class, you would think that all math people do all day is try to solve for x and solve like 100 equations or whatever each day at their job. But when I worked for Department of Defense and we tried to break codes, we would look for patterns, and if you find the correct pattern, you can break the code. And so that's what we're going to do here. We have 2, 5, 8, 11, 14. So you could pause the video and think, well, on all four of these problems, try to figure out what goes in the box. Let's try to find the pattern. So just pause it if you want. If not, well, here it goes. So when you're looking at this, and you may have guessed them all, one common thing to do is so look at the gaps between the numbers. And so look, if we go from 2 to 5, it looks like I added 3. And then going from 5 to 8, I added 3. And then look, I added 3. Looks like we have a pattern here. Add 3. So if I go 14 plus 3, that should give me 17. Now, of course, sequences keep going on, so I mean, you could say, oh, well, the next one's going to be 20 and then 23, but you don't have to do that. But one thing that we want to learn here is that this kind of sequence where you're adding the same number each time has a name, and the name of this sequence is called arithmetic. It looks like arithmetic the way it's written, but it's arithmetic. This is an arithmetic sequence. Okay? Arithmetic sequence means you add the same number, or actually you could subtract the same number as well. So if you have ones where you're always like -2, -2, -2, -2, it's an arithmetic sequence. And I guess the rationale behind that is because subtraction is really just adding a negative number. Let's go over to this one right here. Whoa, let's go down here. This is problem number 2. So like, let's look at the gaps. If I add 5, and then I add 10, and I add 20, so I'm not adding the same number. So I know that we're probably not going to have an arithmetic sequence. So if you looked at this long enough, you might see that if you double 5, you get 10. Or another way of saying doubling is multiplying by 2. If you multiply 10 by 2, you get 20. 20 times 2 is 40, so this looks like a definite pattern here. 40 times 2 is 80. 80 times 2 is 160. So when you multiply by the same number each time to get the next term, this is called a geometric sequence. Geometric sequence is multiplying by the same number or dividing by the same number. If I divided everything by 3, you're really multiplying by 1/3. So multiplying or dividing by the same number, geometric. adding or subtracting by the same number is arithmetic. Let's move on to this one right here. Let's see, if I add 3, I get 5. 5 plus 3 is not 7, so it's not arithmetic. Multiplying, well, this is going to be ugly. Multiply 2 times what gives me 5? Well, then, if you thought about it really hard or you wrote down an equation, it would be 5 halves. But then 5 halves times 5 is not going to give you 7. So this is not going to be arithmetic. It's not going to be geometric. And maybe you saw the pattern here because you saw the lecture before this lecture that was called Fibonacci numbers. That was part of it. And look at this. These are not Fibonacci numbers. It's not the Fibonacci sequence, let's say that. But look at this. 2 plus 5 is 7. 5 plus 7 is 12. 7 plus 12 is 19. 12 plus 19, so that is the pattern. 12 plus 19 happens to be 31. So this is not arithmetic, not geometric. It's not even the Fibonacci sequence, but we're going to say that we're going to call this Fibonacci-like. So that's what we'll call it, Fibonacci-like sequence. Okay, because it kind of acts like the Fibonacci sequence, but it's not identical, so that's why we say Fibonacci-like sequence. So there it is. Okay, let's go ahead and do this one right here. The first thing I always do is look at the gaps between the numbers. So I add 2, and then here I add 3. Okay, so it doesn't look like it's going to be arithmetic because it has to be the same number I'm adding. Geometric, multiply by 3, nope. Fibonacci-like, 1 plus 3 is not 6, so it's not going to be any of these 3 kinds. But I'm going to look at the gaps a little more because, when I don't see that it's one of the common kind, I still look at the gaps. I add 2 to 6 to get to 8, and then 8 plus 3 is 11, and 11 plus... Oh, so I do see a pattern. Plus 2, plus 3, plus 2, plus 3, plus 2. So this one's going to be plus 3. And so the answer should be 16. Now your homework is going to ask you to find the next term like we've been doing and classify the sequence as arithmetic, geometric, Fibonacci-like, or none of these. So if you had this in your homework, this would be none of these, meaning none of these 3 kinds of sequences. And so that's how you're going to be doing your homework. We'll do a few more, but before we do a few more, I'm going to put a puzzle in here, and at the very end, we'll come back and do this puzzle. Here is a sequence. It's not like numbers like we've been seeing. It's a sequence of letters. O, T, T, F, F, S, S, E, N. Figure out what goes in the box. At the very end of this video, we'll go ahead and tell you the puzzle. This has nothing to do with if you can do the tests or anything, and some of you might want to just ignore this part. Okay, let's go ahead and do problem number 5. So I put 5 and 6 together. And so the homework directions will say find the next term and classify each sequence as arithmetic, geometric, Fibonacci-like, or none of these. So you might want to pause the video and see if you can do these ones on your own. Okay, so let's take a look at this. Is this arithmetic? Well, wow. For it to be arithmetic, there's a gap between these, and the gap looks like I subtract 24. So if I subtract 24, I get 12, and if I subtract 24 from 12, well, it doesn't give me 4. Well, here's something else. If I divide 36 by 3, 36 divided by 3 is 12. 12 divided by 3 is 4. 4 divided by 3 is 4 divided by 3 is 4/3. So this one looks like we found the pattern, which is divide by 3, or another way of saying it is multiply by 1/3. And some of you like divide by 3 better. It just sounds better. But when we say multiply by 1/3, it might help us with this last one here. So if I multiply 4/3 by 1/3, remember you multiply the tops and multiply the bottoms, so this is going to be 4/9. Oh yeah, look at that, multiply by 1/3. And then I'm going to go ahead, I'm trying to figure out what goes in the box, so I'm going to go 4/9 by 1/3. So this is going to give me, on the top, 4 times 1 is 4, and on the bottom, 9 times 3 is 27. So this is 4/27. So what kind of sequence is this? Well, this one is not arithmetic, but it was geometric. And because I'm lazy, I'm going to go geo, and that's part of the answer. So 4/27, geometric. Let's go ahead and do this one here. Let's see, if I subtract 5, I get -3. Okay, 2 minus 5 is -3, and then I go -3 minus 5. Nope, it's not arithmetic. This one does not look to be geometric, because like going from here to here, you would multiply by 4. -1 times 4 is -4. -4 times 4 is not -5. So it's not arithmetic, not geometric. Let's check Fibonacci-like. What happens when I add these guys? 2 plus a -3. That gives me -1. Okay, so this looks good, but we should check everything on this. -3 plus a -1 is -4. Okay, this is good. -1 plus a -4 is a -5. So this is Fibonacci-like. -4 plus -5 is -9. So this is Fibonacci-like. And there's our answer, -9, Fibonacci-like. And some of you are like, I'm dropping this class because you saw fractions and then you're dealing with negative numbers, but please don't drop the class. Unless you've never worked with fractions ever in your life, then maybe you've placed yourself in the wrong class. Let's go ahead and do 2 more problems and then we'll be done with 1.1. And we'll do the puzzle after these 2 problems as well. Okay, find the next term. That's the first part. And this one looks pretty simple because it looks like it's just alternating. So even without any other knowledge of what we've done in the past, you could probably guess a 3 goes there. Okay, but what kind of sequence is this? I mean, if you check for arithmetic, you add 6 and you get 3, and you add 6 and you get 9. It's not arithmetic. Geometric, what could you be multiplying each time to get the next term? You could be multiplying -1 each time. So -3 times -1 is 3, times -1 is -3. Yep. So this is a geometric series. This looks kind of funky because, you know, we used to use an x for multiplication, and then when we started doing algebra, x was a variable, so that does look kind of dumb that let me just go like this, multiply by -1. And I believe we'll go like this. No one will even know when they're looking at the PDF. Oh, come on, what is with this whiteout? One more. There we go. Multiply by -1. And we got 3's the next term. It's geometric. Let's take a look at this last problem here. Let's start with, is it arithmetic? Well, what should I add to 2 to get to -4? Well, maybe subtract. Subtract a 6. 2 minus 6 is -4. Minus 4, or -4 minus 6 is -10. And then minus 6, -16, minus 6 is -22. So it looks like it's arithmetic. I'm going to subtract 6, and I'm going to get -28. So we subtract 6. I should have just gone minus 6. That's not part of the answer. The answer is negative 28, and then this one's arithmetic. So for the homework, you've got 16 homework problems, and hopefully it won't take you forever to do them. They're from 1.1. Things that I do not assign are problems that look like this. They have stars by them. So if you see a star in the homework, that's probably number 17, 18, 19, 20, those mean that that's just a challenge problem. And the challenge problems are optional. Some of you might complete the 16 and say, oh, I want to see if I can do one that's a little more challenging. Think of it as like breaking a code. And when you are a code breaker and you break a code, I mean, some of you may have paused the video and tried to get some of these and you got them on your own and you were kind of happy because you did that. Just imagine breaking a code that is written by bad people who want to harm the country. You actually feel really good when that happens and you found the pattern. And the patterns are usually a lot more complicated than when you're looking at here. So our very last thing in this video is completing this puzzle. And some of you may have guessed the pattern. So I'm going to go ahead and say something instead of, we could go O, T, T, F, F, S, S, E, N. Okay, so now I'm going to say it a little differently. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this one is 10. And so that's the answer. It's T. Now, if some of you are like, what just happened? 1, 2, 3, 4. So these letters are what starts the word 1, and then this letter starts 2, 3, 4, 5 starts with an F, 6, 7, 8, 9, 10, T-E-N. So that completes the puzzle. We're done with 1.1. Our next section, it's like we'll be getting into 1.2 and 1.3.